Half a billion years ago, the world felt different, though the map of continents had not yet finished its slow rearrangement, and the shorelines where they existed were quiet and empty. The sound of wind on land was the only sound, because life, complex life, lived almost entirely beneath the waves, in oceans that rolled and shimmered under a pale sun. In those deep, slow seas, something unimaginable, something small and incremental changed everything. For the first 3 billion years of the planet's history, life had been patient, almost invisible single cells. Crowded mats of microbes, strange colonies that left texture on rocks, but little in the way of motion or drama. Organisms drifted, they floated, they lay anchored to seafloors and to stones. They fed where the currents brought food. Mobility, deliberate, muscular, searching movement, was rare or hidden or simply not yet necessary. Then, in geological terms, in a breath that still measured millions, animals began to move. Not as a single thunderclap, but as a bloom of experiments. Worms and paddled swimmers, small hunters and grazers, creatures testing the sea in new ways. They crawled, they burrowed, they swam, and in doing so, they rewrote the rules of life on Earth. Around 530 to 520 million years ago, in a period we call the Cambrian, the planet saw an explosion of body plans, a sudden flowering of shapes and behaviors that created most of the major animal groups we still recognize today. But the story begins earlier. In the older, dimmer world of the Ediacaran period, long before armored trilobites or swimming hunters dominated the sea, there were traces, faint, fossilized paths across ancient mud. They are not bodies. They are the records of bodies, impressions left where an organism pushed against the seafloor and inched along, like the first wayfarers across a newly opened road. In rocks dated well before, scientists have found these trails, evidence that animals were already probing their environment, testing the ground, feeling the world with movement. These trace fossils remind us that motion did not appear. It was a gradual unlocking of new possibilities. With movement came intention. An animal that could crawl could choose where to feed. An animal that could swim could escape or chase. Once locomotion existed, natural selection could shape it, refine it, and twist it into countless solutions. Muscles, however simple, offered advantage. Sensory organs that detected light or vibration became priceless, body armor. Spines and shells appeared where once only soft, vulnerable tissues had been. The ocean became a theater of interaction, of attack and avoidance, pursuit and escape, of new ecological roles appearing. The Cambrian seas were populated by weird and wonderful creatures, many of which have no perfect modern analog. Trilobite, with their segmented, jointed exoskeletons, scuttled across the seafloor like armored beetles. Simple worm-like animals grazed microbial mats, leaving sinuous furrows as they fed. Filter feeders extended comb-like appendages into the flow, sieving particles from the water. And then there were the hunters, swift, efficient. Among them, the radiodonts, of which Anomalocaris is the most famous, were apex predators, with powerful frontal appendages and a circular, tooth-studded mouth capable of gripping and slicing. They gave early ecosystems drama. Not only were organisms moving, now they were chasing one another, and life had become a story of encounters. Predation drove an arms race. As predators refined ways to seize and consume, prey answered with armor, spines, shells, and with hiding. Burrowing became an innovation of survival. Creatures that tunneled into soft sediments could escape the eyes and grasping limbs of hunters. Burrows themselves changed the planet, aerating seafloor muds, altering chemistry, allowing new microhabitats to form, and in turn enabling yet more life to take hold. Motion reshaped environments as much as bodies. Fossil beds from that time are filled with the relics of those experiments. In places like the Burgess Shale, we find the outlines of soft tissues, the fine structure of limbs. Detail of eyes and entire communities are frozen in moments of time. Trilobites appear in abundance, their mineralized armor a clear marker that skeletonization had become widespread, a change that left records. These fossils, when we gaze at them, feel almost alien, and yet within their forms are the seeds of everything that followed. Why did this happen when it did? Scientists offer explanations. Oxygen levels in the oceans and atmosphere are central to the story. The slow accumulation of free oxygen over billions of years set a stage on which larger, more demanding bodies evolve. When oxygen reached thresholds that made sustained activity possible, evolution seized the opportunity. Other forces, nutrient flows, the breakup of global environments into new shallow seas, genetic innovations combined to innovate. The world had become capable of supporting motion at scale, and life responded in kind. Imagine the Cambrian Ocean at dawn, a world of soft light, of slow currents beneath which lives. A segmented creature flexes its muscles and inches forward, antennae quivering, searching for bacteria. A small, armored trilobite flicks its legs and skitters into the shadow of a rock. Somewhere predators, movement changed scale as well as form. Where life had been bound to place, now it could travel. Where feeding had been passive, it became active. Where competition had been rare, simple nervous systems developed to coordinate these new movements, and with nerves came behavior, the earliest decisions, the first acts that could be called seeking or fleeing or attacking. The record reveals. What survived, however, set a template for life to follow. We are descendants of that motion, of the animals that first dared to move. Because once movement existed, evolution could run, and it did.